everyone, my name is Tanagodchaporn, the student from Pราชว School. Today, I'm proud to present you about the astronomy project. The title is The Study of Physical Parameters of Wolf 127b. First, I will let you know about the exoplanet and the cause why should we study about them. The exoplanet. Exoplanets in the easy way are the planets that orbit around other stars outside our solar system and form the mysterious questions that have faced to humankind for the century, like why we here, how did the planet form and evolve, and what about the future, what will be happen. So study about exoplanet can help us to understand and answer these questions. Studying about exoplanet. Studying about exoplanet have a very several methods, but the basic method is transit method. The transit method is the photometric method that is measure brightness of the distant star to find the periodic dip in their light curve. This shows the result when the planet passing in front of the star. And this is the example of the result that we got from the transit method that called the light curve. Absolutely, we must have the target. The target in this project is Wolf 127b, this one. This planet is orbiting around the star named Wolf 127. The Wolf 127 is the bright G5 star that about to leave the main sequence. This planet have a very large radius, about the Jupiter radius, but the mass is about the Neptune mass. So this planet is one of the lowest density planet that we have discovered to date. With this reason, this planet will have a very thick atmosphere. And the interesting thing is, if we analyze the atmosphere, we will know about the chemical composition of this planet. This slide will show you about the working step. First, choosing the target by using the website exoplanet.eu. We consider about the period. The period of this planet must not too long because we have a limited time to observe. And then we consider about the star magnitude. The star magnitude must less than 13 because of the observatory. And then we consider about the position. The coordinate of the stars will in the right position that our telescope can observe. And then we calculate the transit time by the period. Then we observe. We observe with 3 telescopes. We combine the data from the previous data in 2017 with Thai robotic telescope in China and in Thailand. And this year, we combine more data from the Thailand National Telescope in Thailand. And then we analyze the data. We analyze the data by using the automated photometric pipeline to plot the light curve, and then we analyze the light curve to fitting the parameter by MCMC. These are the objectives about the parameter fitting and the atmosphere. This slide will show you about the pipeline working step. The pipeline will specify the location of the star in the images, and then measure brightness of all stars in the images, and choose the reference star but different photometry, and then plotting the light curve. These are the results from Thai National Telescope with the U-band. This from Thai National Observatory in the I-band. And this from Kamaigu Observatory in the R-band. Then we use the Batman. Batman is the Python package that will generate the light curve, and then MCMC or Markov chain Monte Carlo will fitting the parameter. And we get this The result is the from MCMC fitting, and from the result we get this table. This table will show you about the parameter for fitting that include period. A is mean that semi-major axis, and RS is mean the radius of the star. RP is mean the planetary radiance. I is mean the planetary inclination. Then we use the parameter for fitting before to calculate and get the planetary parameters that include by semi-major axis, mass, radiance, density, temperature, and logarithm of the gravity. This slide will show you about the comparing of the Wolf 1 to 7b orbital elements from our analysis and from previous study. That you will see all of the value in this work and in the previous study will have a quiet sync. So the conclusion is the parameter of Wolf 1 to 7b from our observation type will be the previous study within 1 sigma error. This slide will show you about the result about the atmosphere. This graph is plotted by transit depth and the wavelength. The transit depth is like the size of the planet. And this plot is from the previous study. And our plot is this green plot. The plot is from R and I band. In R and I band is have the value that close to the previous study, but you will see it have a little bit higher because of the range of the wavelength that's so wide. So this plot is from the average from the plottings in this wavelength. But the interesting thing is this plot. This plot is from U band. It's special because no one has observed before. So you will see it more higher than other plottings. That will tell us about in this U band, the planets are bigger. So the conclusion is we will confirm that it has the haze in the atmosphere and the sky in planet. It has the blue sky like the sky on Earth. So this is our reference. And I want to thanks to Assistant Professor Dr. Sirumat Komunjinda, Dr. Supachai Avipan, Yuparai Vithayalai School, Faculty of Science, Chiang Mai University, DPST and IPST. Thank you.